So now we go to this example 1b. The question asks us to check whether these two lines are parallel or coincide, intersect or skew. So now we follow step by step. We start with the step number 1. Step number 1, we have to write equation in terms of symmetric form. Means that here we have our L1, the equation is x minus 2 divided by negative 4, which is equal to y minus 1 divided by 1 equal to z minus 1 over 2 divided by 5. And then for L2, we have here symmetric form of the equation x divided by 3, which is equal to y plus 2 divided by negative 1, and then equal to z minus 4 divided by negative 2. In this case, from here we can find its vector direction, which is given by, for the first L1 is negative 4, 1, 5. How do we know about this? You have to take this value. This is A, B, and C. And then for the second line, we have a vector direction 3, negative 1, negative 2. So now our second step, we need to check if we can write our direction vector of L1 and L2 in terms of negative 1, negative 4, 1, 5, which is equal to some value of t, 3, negative 1, negative 2. And then we can, if we can find the value of t that satisfies this equation, means that the equation may be parallel or coincide. But in this case, if you look at this vector, there is no kind of t that fulfill this equation. Because here, if I write negative 4 equal to 3t, I will got here t equal to negative 4 over 3. But when I substitute in the second terms here, the second terms here 1 equal to negative 1, this negative 1 times t. But here, t should be equal to negative 1. So it is not equal. Means that here there is no value of t that satisfies this equation. Means that our line L1 and L2 is not parallel or coincide, but it is maybe skew or intersect. So we will have here our L1 is given by x equal to 2 minus 4t1, y equal to 1 plus t1, z equal to 1 over 2 plus 5 t1. And the equation of line for L2 is given by x equal to 3, 2, y equal to negative 2 minus t2, and z equal to 4 minus t2. Then how we can solve for this one? First, we can check whether there is intersection point or not. So we need to make all equation for L1 equal to all equation for L2. In this case, this x will be equal to this x, this y for L1 equal to y for L2, and z for L1 equal to z for L2. So we will have here 2 minus 4t1 equal to 3t2, which is this imply that our 3t2 plus 4t1 equal to 2. This is our first equation. And then we have 1 plus t1 equal to negative 2 minus t2, which is imply that when we arrange, we have t1 plus t2 equal to negative 3, and this is our second equation. And for z, we have 1 over 2 plus 5t1 equal to 4 minus t2, which is imply that when we rearrange 5t1 plus t2 equal to 7 over 2. This is our third equation. Then we can solve simultaneously for t1 and t2. So we use equation number 1 and 2 to solve for t1 and t2. Once we got t1 and t2, we can substitute in the third equation. When we substitute in the third equation, if it is fulfilled this equation, so we can say that our line is intersect. So we check here. When we solve simultaneously for equation 1 and 2, we will have here for equation 1, I can write T1 as subject. So I have T1 equal to 2 minus 3T2 over 4. And then once I have this T1 in this expression, I substitute this T1 in second equation here. So I have here 2 minus 3T2 divided by 4 plus T2 equal to negative 8. Based on this, we can solve for T2. Once we solve this, we'll got our T2 equal to negative 5. Now we have here T2 equal to negative 5. So we can substitute this T2 in this equation. Instead, we will have here T1 equal to 2 minus 3 times negative 5 divided by 4. When we solve this, we got the answer equal to 17 over 4. And then once we got this answer, you already have here your T1 and you have here your T2. So this 2T we can substitute in the third equation. When we substitute in the third equation, we have 5 times T1, which is 17 over 4 plus negative 5. Then we solve this one, we'll got the answer 65 over 4. This answer is not equal to this answer. Means that it is not equal to 7 over 2. So L1 and L2 are skewed. It is not intersect.